the way about doing this question, you'd realize it's translation the moment you see that A, B, and C, they've definitely, undoubtedly changed positions. Like, they're definitely shifted across by a certain number of spaces. That you can tell it's definitely going to be translation. So you write down translation. And the reason why you only write 0, negative 2 for this particular translation vector, as in you see this bracket over here, 0, negative 2, you might be wondering, why don't we write anything in the horizontal direction? Because we know by now that this number represents the horizontal distance change. It's definitely changed the horizontal distance, but why have we written 0? The reason why is because A to this, B to this, C to this. Notice how the horizontal directions are inconsistent. A goes across by 1, B goes across by 2, and C goes across by a whopping 4 spaces. That's why you can't really write anything over here. The only thing they have in common, really, when they're changing positions is actually downwards, isn't it? Look at A to this. A to this new point is downwards by 2. B to this point is downwards by 2. C to this new point is downwards by 2. That's the only thing that all three of these points have in common in terms of translation over here. And that's why we write negative 2, because negative 2 represents downwards by 2. So that's the first transformation over here. How did we know it's going to be stretched? We know it's going to be stretched because look how much longer this became. Look at this original shape and imagine if you did stretch it. What would look like the direction it was stretched in? I mean, common sense tells you it's definitely in the horizontal direction it was stretched, isn't it? It got squished into a more wider orientation as opposed to a vertical orientation. Remember, stretch is only applicable in two directions over here for AS. It's either horizontal or vertically stretched, and you can tell it's going to be horizontally stretched. And how do you know how much by horizontally it was stretched? Look at this. Originally B to A. The new one is B to A is 2 spaces across. You can tell it got wider by what? B to C, originally 2 spaces across. B to C is now 4 spaces across. That's how you could tell it was going to be stretched parallel to the x-axis, because horizontal direction, that's how we describe it. We mentioned it as parallel to the x-axis, and the scale factor tells you how much it was stretched by. Hence, these are the two transformations over here. Number 2. Remember when you're doing this question, just go straight to when they say f of x is bigger than 2, you know there's going to be a certain relationship that you can depict over here, which is x squared minus 6x plus c is bigger than 2. The comprehension you need to have over here is, as in, do you interpret that when they're asking you to find all the possible values of c, they're saying, hey, this is the relationship. This expression over here, notice how the c is undefined? If it's undefined, that means this graph could be anything right now. Like f of x, this equation, this number could be anything depending on what the c is. If they're saying it has to be bigger than 2, yes or no? Are they saying it has to be bigger than 2? Do you follow this? Yeah? If it has to be bigger than 2, that means this particular equation has to be bigger than 2, just like this. And you're trying to find, just starting from here now. This is everything they've possibly given to you that you change into equation form. You're supposed to now work just from this. What can you get about the c? Like, what sort of relationship can you deduce? What can you extract from x squared minus 6x plus c bigger than 2 to be able to describe what the different values of c are going to be? As in the set of possible values of c, as in you're trying to describe what the different numbers that represent this letter are allowed to be, have to come from the second line of working over here. Where do you go from here? X squared minus 6x is no good to you right now, is it? Do you see how, like, this thing as is, there's no really sort of relationship you can extract over here. Like, this, it's kind of inert. There's just nothing really more to it. You would think to move all the stuff to the left-hand side, because when you move all the stuff to the left-hand side, guess what? This third line of working, does it just make sense? The third line of working looks more intuitive, isn't it? Like, this is something you're more used to. Remember this type of expression, the third line? That's how you would think to go from the second line to the third line. You would attempt this, yes? I'm explaining to you that when you're doing this question, the best case scenario, there's certain students that will just be like, best case scenario, they can just tell straight away what the relationship is for C. But I'm saying for most of you students out there, if you don't know the relationship straight away, you need to be able to work it out. You need to start trying different things. So I'm explaining to you that second to third line of working is something you try out. It would just make sense to try that out. Because a clean quadratic expression, something x squared, number x, plus an overall number bigger than 0, that's more easy to look at, isn't it? Do you agree? Yeah? And then from there, you'd realize, remember what technique exists? Do you have this awareness? There's a certain technique that exists where you can take something that's a quadratic and make it into completed square form. Because a completed square form, what? It makes it very obvious sort of what limitations it can be. When you write completed square form, you take two x's and combine them into one x, isn't it? And you'll see why this helps, okay? Best way to understand this, if you don't quite get it just yet, look at how this does help. Look at what happens when you do complete the square. Let's focus on if you do complete the square, what happens? First off, you need to know how to complete the square. You're not confused about why x squared minus 6x. You are not confused about how x squared minus 6x became x minus 3 squared minus 9. Yes or no? That's the basics of completing the square over there. And then if you have minus 9 minus 2, it becomes minus 11. Right? It's just simplification. You don't need to be told that can be simplified. And take a look at when it gets to this line of working. Can you see my cursor, my mouse? Do you see how x minus 3 squared, this is unique. Anything to the power of 2 can only ever be positive. The smallest possible expression it can be is 0. X minus 3, no matter what, it's going to be positive. So if you know that's already going to be positive, look at what you really have in front of you. You're trying to have x minus 3 squared plus c minus 11. That overall thing has to be bigger than 0. If this part you already know, This is what they're testing on. Hey, oh, I can tell this is overall going to be positive. It has to be bigger than 0. And if I add this onto it, overall, it still has to be bigger than 0. Doesn't that mean the thing I add onto this thing that already is bigger than 0? X minus 3 squared is already bigger than 0. Whatever I add onto that, in order for the whole thing to still be positive, c minus 11 must also be bigger than 0. That's where you get this relationship. Because c minus 11 being bigger than 0 is written by c minus 11 greater than 0. That inequality. Which then you can solve for c greater than 11. See how that works? Okay? So that question would have been solved if you completed the square. And this is what you just need. The key takeaway over here is, if you see an equivalent question like this, how would you know to complete the square? Completing square exists. It really helps whenever you have something where you're not sure what the limitations are. You're not sure what overall numbers the answer can be. If you want to make something more clear, if you have a quadratic and you want to make the overall answers, to sort of see the full picture better about what numbers it can take on, that's when you complete the square. Whenever you want to take x minus x squared to the power of something, yeah, anything to the power of 2 involving another x, if you want to change it into one overall x squared expression, to make the whole thing more obvious in terms of what it can and can't be, that's when you complete the square. This one is just binomial expansion. Remember the basics of binomial expansion over here? Let's take a quick detour over here. Do you recall that if this is your expression over here, x plus 2 over x 5 squared to the power of 5, if you have you are not confused at all about why every single component, when you expand this, like you know that x plus 2 over x power 5, just basics over here, you know it's going to equal a bunch of terms, right? A number plus a number x plus another number x squared plus dot dot dot, that kind of thing. Yeah? And you know every single one of those terms in there comes from the triple set of brackets, which is, you have the a and b over here, it always starts off the same, x, 2 over x, and then 5 like this. And you just put the numbers over here. Okay? That rings a bell? So we just did the same for all these ones over here. The x power 5 would have just come from what? In case you're wondering. Actually, no, you should definitely know this. This is basic. Part B. This is where you realize if you have a plus b squared times x plus 2 over x to the power of 5. Listen very carefully. X plus 2 over x to the power of 5. Is that a very long expression overall? Is it? Let's have a look at this. Let's put this into perspective over here. This is what's really going on. As in, they're really testing you on, hey, if this is what we have, and we want to find what a and b is equal to, yeah, they're trying to find what a and b is equal to. If you read the question over there, they're trying to find what the values of a and b are, and they tell you this is the information. This is the information they give to you to allow you to work out a and b. First off, this is the base knowledge you need to be aware of over here. Like, if you are not aware of this information, this sort of relationship, if you didn't pick up on this, there's no way you don't do the question. You'd have to understand that this over here, this is this, no question about it. So if you had this multiplied by this, it's really just the what? This, because it's this whole thing, this multiplied by this is just the same thing as this multiplied like this. A plus bx squared. Okay? And you realize, remember the basics of algebra over here, when you have two brackets? It's always the first component in the bracket multiplied by the entire second bracket, and the second component multiplied by the entire second brackets, which is the first component over here times this, plus bx squared multiplied the second component over here. Pause this if you have to. Take a second to process this. This is very important. As in order to do this question over here, if you are confused, you need to have this relationship very clear in mind. You need to spot that a plus bx squared times this is just the same thing as a multiplied by this whole thing, plus bx squared times this whole thing. Are you following this? And if you were to do a multiplied by this entire thing, since you know x plus 2 over x to the power of 5 is this expression over here, doesn't that just mean a is multiplied by this, this? Every single individual term inside this is multiplied by a. Every single term inside of this is multiplied by bx squared. And now my point is this. If they told you, right, that the coefficient of x is 0, doesn't that mean you want to find the coefficient of x then? Are you confused at all why we need to find the coefficient of x? So if you wanted to find the coefficient of x, it comes from what? You know that a is multiplied by everything inside of here. As in everything inside of here which is this, gets multiplied by a. Do we give a flying fuck about a multiplied by x to the power of 5? Does that really have any relevance for the coefficient of x? Does a multiplied by x to the power of 5 give you a coefficient of x? Does it? Does it for this or this? No. Or does it? Do you really not care about a multiplied by 40x? Is this something you care about or not? In the context of coefficient of x is 0. This is something you care about, isn't it? Do you see my point? You know that a is multiplied by everything inside of here. This is your awareness. And you know that the only thing you care about a being multiplied inside of here, which you know is this whole thing, is a being multiplied by what? The 40x. Because you know a ends up getting multiplied by every single one of these terms. So therefore, this is what you drop down. A times 40x. That's what we have for this first line of working. So far so good? That's why we have this first line of working. Okay? A times 40x, which gives you 40ax. And the next part over here is, isn't it just going to be bx squared multiplied by everything inside of here? And we only care about bx squared being multiplied what? Bx squared multiplied by what inside of here gives you the x term? It's going to be bx squared times which thing inside of here? It's going to be this, isn't it? Any confusion about why bx squared multiplied by at over x is going to give you the x term? Coefficient of x? See that's what we did over here? Bx squared times at over x over there. And you should not be confused about how that simplifies into atbx. And since we took this entire expression, we found the only components involving the coefficient of x is 40x and atbx. We can combine those two to get an equation here, can't we? Because the overall coefficient, because think about it this way, right, you know this, 40ax plus atbx, those are the coefficients of x. Isn't that the same thing as factorizing like this? That's another way of expressing it, isn't it? Meaning the real coefficient of x is what? It's 40a plus atb, which the question told us is 0. See what we did over here? We found two, we linked these two together to get one equation here, didn't we? If you want to find two missing numbers, you need two equations. Two equations comes from where? Simultaneous. Simultaneous comes from where? Taking information to give to you and writing equations. See, we got the first equation already. All we got to do next is what? You can see where it's going. Its coefficient of 1 over x is 80. That's how we're going to get a second equation. And we use the same principle over here, didn't we? Because we use a multiplied by everything inside of here. What is going to give you the 1 over x coefficients? It's going to be a being multiplied by what? This number over here, isn't it? ATA over x, yes or no? Because that's the same thing as ATA bracket 1 over x. See how that works? And that's why we've done that. A times AT over x. ATA over x. Just like over here, bx squared being multiplied by what inside of here is going to give you 1 over x. It's going to be bx squared multiplied by, is this one? This one? This one? Or is it going to be? Which one is it? It's not this one either, is it? Do you see why it's going to be this one? Because bx squared bracket at, this is just algebra at the end of the day, right? At bx squared over x to the power of 3 slashes out like this, isn't it? Which is atb divided by x. Okay? So do you see how we found the two coefficients of 1 over x over here, which we can combine? ATA combines with ATB. ATA over x plus ATB over x, like this, gives you ATA bracket 1 over x plus ATB. This is just if you really have to see it to understand this, right? But you should be able to just tell this from arithmetic. As in, just off the top of your head, just looking at it, you know how the relationship works out. As in, you can tell the clear coefficient of 1 over x is going to be AT. And then this is just something you can solve using what? This is just simultaneous, isn't it? This is very basic simultaneous, so we're not going to go over this. I didn't really include the working for how you solve the simultaneous over here. This should be very, this should be very self-explanatory, yeah? To get these two numbers for A and B. Also keep a note out. If you type in mode on the calculator and you press equation 5, remember there's also, if you have the best calculator money can buy, there's also a feature on the calculator that allows you to work out simultaneous equations like this, which is equation, right? Option number 1. The A, B, and C refers to the 40, 80, and 0. 80, 80, and 80. Try that. Type it in. 40 equals, 80 equals, 0 equals. So shortcut is modes. Press 5 for equation. You press mode, you press 5 for equation, you press number 1 for simultaneous. And then you do 40 equals, 80 equals, 0 equals. 80 equals, 80 equals, 0. Excuse me, not 0, 80. Press equals, and then you get x equals to 2, y is equal to negative 1. Which you can tell corresponds to A and B. to a negative 1. If you wanted to use your calculator, double check this. This one, it looks complex except what? You just need to know the first line of working over here. Meaning, if they want you to show that this equation can be written into this form, the only way to do that is what? You just show exactly how you changed every single component in here overall and simplified, expanded, simplified to get something that only involved cosine. How do you go about doing this? If you have 3 tan squared minus 3 sine squared minus 4, see the final product? So intuition over here is what? Common sense tells you if the final thing only contains sine and what you have over here is tan and sine, you need to change the tan and sine. Agreed? And if you look on MF19, go to MF19. What exists on MF19? MF19 has what? It tells you that tan and sine can only be changed into what? Tan can only be changed into sine over cos. Sine can only be changed into 1 minus cos. But you can tell that's definitely the first step, isn't it? That's going to help. Because you know for a fact these two need to be changed, which is what we did the first line of working. Algebra, we trust the algebra. We just do 3 tan squared recognizes 3 multiplied by tan squared, which is 3 times sine squared over cos squared, minus 3 sine squared minus 4. Next step, if you have 3 times sine squared over cos squared, isn't that just 3 sine squared over cos? I will write out the algebra here, just in case. Just in case you need to see it. So what we've done over here is, this is just in case you need to see the algebra. If you already understand the question, look at the working, then just move on. But if you need to look at the algebra, how exactly it simplifies out, have a look at it this way. Isn't this just going to be, so this first line of working becomes 3 sine squared over cos squared. And we're going to use some abbreviations over here, okay? Because we're very C's writing sine x like that. S represents sine x, C represents cos x. This becomes what? 3 sine squared over cos squared minus 3 sine squared minus 4 equals to 0. Do you see the final thing doesn't have a fraction? It's just one line of working, isn't it? It's just one line, one expression involving cosine. We don't have a fraction over there. We want to get rid of that fraction. How do we do that? Easiest way, just multiply both sides by cos squared. See how that works? Right hand side doesn't change, obviously, since anything multiplied by 0 is just 0. This multiply just cancels out like that, doesn't it? Which is 3 sine squared minus 3 sine squared times cos squared, 3 sine squared cos squared minus 4 times this. Remember the rule for brackets, multiplication like this? And do you see that's 3 sine squared minus 3 sine squared cos squared minus 4 cos squared? See how that corresponds to this? 3 sine squared cos squared, sine squared cos squared, cos squared. See how that works? That's how we went from this to the last line of working. And you realize the only problem over here is what? What you have over here is cosine. What the final thing has is just cos. Therefore, you must what? You must change everything into, from the sines into the coses, because the sines are the problem over here. So you convert the sines into cosine, like this. Sines into cosine, sines into cosine, just like that. And over here, you just trust the algebra over here. You just individually expand first. Don't worry too much about doing this just in one step. You have a bunch of brackets over here. You need to get rid of those brackets. You can trust the math over here. Just do the expansion. What I recommend over here is this one's very easy, right? That becomes this. But when you have different brackets multiplied together, just do everything one by one. Meaning minus 3, just focus on combining this first down there. And if you combine this first down there, doesn't it just become cos squared minus cos to the power of 4, just like this? Cos squared minus cos to the power of 4 times 3. See how that works? And then just simplify with one more step down there. Anyways, this should be pretty self-explanatory how this eventually became what you need to prove over here. And you're not confused by A, B, and C. A, B, and G is just telling you they just need to be constant numbers in front of there, which you've proven. A, B, and C. See how that works? When they say hence solve the equation, this equation looks fucked, except you realize this is the same thing as what? They already told you over here. Solving this equation is the same thing as, notice how this equation was rewritten into this cosine? We have the exact same expression, isn't it? Meaning you realize solving this thing, solving this 3 tan squared minus 3 sine whatever, is the same as solving what? This cos expression, which is what you have over here. Are you confused at all why instead of doing this, we can just do the 3 cos one instead? Because we changed this. It came from the same expression, didn't it? If this becomes this, if the fucked up looking tan and sine one becomes something just involving cleanly only cosine, aren't we allowed to just solve the top one by just solving the bottom one instead, which is much easier? Does that register in your mind? Does this compute? Yeah? And we realize doing that is just what? Isn't that just the same thing as substituting? I mean, this is the same thing as a quadratic relationship, isn't it? This is one of those questions where we let a certain number equals what? We let a certain number equal to cosine squared, and we end up doing what? Say example of alpha. If alpha is equal to cosine squared, we end up getting 3 alpha squared minus 10 alpha plus 3, which is a quadratic. And that's what we've done over here. We've realized this can be factorized to this. If you need to see it, here's what happens. So what we've established so far is we can do this question over there We can do the bottom question, solving this equation for between 0 and 180, by just doing what? By just solving this equation instead. Because we already proven in the first part it can transform into that. Isn't that just the same thing as saying let alpha is equal to cosine squared like this? Which becomes... How could you tell it's quadratic? Because remember the real definition of quadratic? A quadratic is just really a relationship. If you have an overall equation over there and the differences between the variables are exact square relationship, that's the real definition of quadratic. Quadratic doesn't mean you have to have a letter x and x squared like that, no. It's just anything that has exactly only a square relationship between each other for the variables. As in you see the cos squared and cos power 4, they exactly have a square relationship, don't they? Hence, we can say that's quadratic. That's how we'd be able to tell. But also, most of the time when you're doing these questions, the students who are really, really good at this, it's just because they've seen this so many times already. They just pick up on it. Math is one of those things where it's tacit. Like a lot of it is just foresight. You just spot it from a mile away and just do it, if you're really competent at it, right? From experience. But anyways, this question over here, you can solve that. You have the best calculator money can buy? Of course. Do we even want to factor it? Like, just calculator it. Modes. Number 5 for equation. Number 3 for quadratic. Press 3. Press -10. Press 3. It gives you x equals to 3 and 1 over 3, which means, by default, it means, what? 3 alpha minus 1, alpha minus 3, like this, isn't it? Remember the trick? You can use the calculator to easily factorize this in one step, straight away. And remember, because this 3 alpha minus 1 is equal to cosine squared, that's the same thing as what? 3 cosine squared minus 1, bracket cosine squared minus 3, like this, equals to 0. See this? This is the same thing as 3 cos squared in this. Why do we transform it back? Because we're trying to find x, aren't we? Not alpha. So that explains this line of working over here. And then we just solve it. We know only one of the brackets needs to be 0 to make the whole thing 0. So we make this thing to 0, and we also make this thing to 0. That should be self-explanatory. We can continue with this. This is just rearranging. The reason why we cross this one out is because, well, think about it. Cosine squared equals to 3 is the same thing as cos x equals the square root of 3. Type in the square root of 3 and you'll find it's a number bigger than 1. Can you do shift cos of anything bigger than 1? No. Also, if you were to solve the second part, you'll find it's going to be math error. So, yeah, cancel that one out. So this is the only valid answer we have. Remember, square root is always plus or minus. If you do square roots of 1 over 3 for cosine, do this. Type in shift cos. Make sure you're in degrees mode. If you type in shift cos, do this right now. Square root of 1 over 3. What does it give you? Gives you 54.7. Which is this one over here. Do we have any other answers between this and this? Of course, we've got to do the shift cos, the negative version of that, and that's what we get, 125.3. Okay? Recap. Some of you might really find this struggling, yeah? It's just, we solve this question by realizing this question is fucked. Instead, we can just solve this thing. And why is that allowed? Because there's a rule of algebra over here, isn't it? Algebra 101 common sense tells you if you change this particular thing into this, that means solving this bottom one is the same as solving the top one. So when you go to the second part, instead of solving this, you can just solve the easier version over here, which we proved is relevant from this, because this transformed into this form. And then we just solved this using what? Quadratics. And ignore the ones that were invalid answers. How do we know it's invalid? One, from just knowing that shift cos cannot be bigger than 1. But also just from the fact that the calculator will tell you too, because it's a math error. Number 5. 2 points of intersection. This is just, doesn't matter what type of equation you have. You know, points of intersection always involve simultaneous. It always involves making the 2 different letters into one type of letter. You've got y is equal to x minus 9. You've got another thing involving x and y. Just replace the x with x minus, replace the, y with x minus 9. See, that's what we've done over here, which makes sense to you. And then just expand, do the basic algebra, you end up with a quadratic. You know where this goes. If you get -1 and 7 for the 2 values for the quadratic over here, you can just what? Substitute it back into x minus 9 to find the corresponding y values, which in turn give you the points of intersection over here. Part B, circle diameter AB. This is where you just realize, remember the basics of circles? They're testing you on, hey, do you know for a circle you just need to know the center and you just need to know the, what's the other aspect? There's only 2 things you need to mention for the equation of a circle, which is center and what else? What's the other one? You there? Radius. Right? Yeah, circle equations, you just need to know the center and the radius. So therefore, if you're doing this question over here for the equation of a circle, of course you then find the center and the radius. And then if they're talking about the diameter of AB, you already know diameter AB is this. That's how you're going to find the radius. And how you're going to find the center? If If diameter is AB, if the point A and B is the diameter, doesn't that mean the middle of A and B is going to be the center? And do you have the coordinates for A and B? Of course, you found them in the first parts of the question. A and B are just the first two coordinates you found for part A. So 3, -6, how do we find that? It's just the midpoint between -1 plus 7 divided by 2, -10 plus -2 divided by 2. This is just basics on how to find the midpoint between 2 points. This is A, this is B. Midpoint of A and B is going to be the center of the circle, which is how we did this. Radius is just going to be, isn't the radius of the circle just going to be the distance between the center and any one of the outside points in the circle? A and B are the two outside points of the circle that we know about. Do we have the center? Yes. So isn't it just going to be the distance between the center, 3, -6, to any one of these points? So we just choose 3, -6 to -1, for example. 3 minus -1 squared plus -6 minus -10 squared, square roots. This is just a distance formula. You should definitely know this, yeah? And then obviously once we have the center and the radius, it's just going to be what? X minus 3 squared plus y minus -6 squared equals 2. Radius squared, which is 32. That's just the general formula for an equation of a circle. For circular measure questions, always remember, especially for relatively large number of marks, like 5 marks, you can tell this is multiple parts to it. Best way to go about doing this, do not, first off, get disorientated by the diagram over here. You just think about it this way. What would the 10-year-old version of yourself be thinking about when you do this question? What I'm trying to highlight over here is, before you even look at the numbers, don't start tripping, right? Don't look at the numbers or whatever. Look at, if you want to find the area of the shaded region, just identify what even makes up the shaded region. That's the first point. That's why we've written this as the first line of working. Yeah, if you focus on what even gives you the shaded region, that's sort of how you guide your question here. That's how you end up arriving at the right answer. Once you've identified first step, right? First thing we do, what even makes up the shaded area, write that down. Doesn't matter if you want to do it in words even, right? You'll see how this helps because we know it's going to be the overall slice, the pizza slice or whatever, portion of the circle minus the triangle inside. See, that's what we've written over here. That's how we've outlined. Then we can just say what? Let's focus individually on the sector of the circle. It's much easier to keep track of one thing at a time as opposed to all of it in one line of working. Are you following this so far? So this is where we just do the sector of the circle over here. This is where we just look at the sector of the circle. And if we're doing the sector of the circle over here, isn't that just going to be the 1/2 theta r squared equals to 76.8? Because we need to know, like you can tell over here, when they're asking for the area of the shaded region, they're clearly asking us to do what? They're clearly asking us to find an actual number for our final answer. So if we're looking for the area of the shaded region and we're looking at the sector right now, we clearly have to use this information, 76.8, to work out what the missing angle and the radius is. And the only way we can do that is to write down what the area formula, area expression, which is 1/2 theta r squared equals to 76.8. What's the other one? Theta r is equal to 9.6. See, that's what we've done over here. There's only two pieces of information to give to us, and we put them over there because we know in order to work out what the actual area of the shaded region is, we better find what those missing two numbers are. And we write this is where you realize, hey, 1/2 theta r squared. So in case you need to see the logic over here, how exactly we did this part of the working. This is just where check out what we did over here. Like how exactly, so you know why we have these two pieces of information over there written like that? Because that represents sector area, that represents arc length. This is where you realize 0.5 theta r squared divided by theta r. Why would we think to do that? Because do you see very conveniently when you write them, they can cancel out each other if you divide them, is my point. See how that works? If you make this divided by this, like why would you think to do that? You'd think to do that because if you can just very conveniently get one of the letters by themselves, see how that works? No? See how perfectly that works out? Like it just cancels out like that, doesn't it? To get r by itself, one letter by itself, you just worked out r is straight away like that. Yeah? Obviously, once you work out r, you can definitely work out what theta is, because theta times 16 is 9.6, and that's where you got 0.6 from. And then without further ado, this is where you keep going with the question. You'd find what r and theta is. Once you find what r and theta is, you now work on the triangle. That's what we've done over here. Let's focus on the triangle. See what we're doing? Like very step by step. Very like aspect by aspect. Just one thing at a time with these types of questions. But obviously the first line of working is to always what? Just identify what even makes up your final answer. And then you have the triangle over here. Can you not just write down what the triangle is now? You've already found what this missing angle is. You've already found what the missing radius number is. And remember the universal triangle formula? In case you've forgotten, universal triangle formula. Remember there's two formulas of the area of a triangle? The most common one we've done since primary school, right? A half base times height. But the less common one, which is applicable for any type of triangle, because the primary school one only applies for writing on triangles, doesn't it? Yeah? This one over here is what? It's just going to be any triangle area can be found by doing a half multiplied by the two sides that make up a particular angle multiplied by sine of one of the angles. This is just basics from IG. And that's what we've done over here. Because we want to find this one, it's just going to be a half r times sine of this angle, which is what we've done over here, okay? See that works? A half times radius squared times sine of the angle, which is this. We don't even write down the rounded version, we just write down exactly what that would give us, which is 128 sine 0.6, and we just plug it in over here. So area over here, which is sector minus this, we already know the sector is 76.8, they give it to us. So we just copy that in, 76.8 minus whatever area we found over here for the triangle, and just do the math on the calculator over there. Perfectly correct. Part B, perimeter of the shaded region, same principle over here. We don't trip on the numbers or whatnot, we just, like, what even makes up the perimeter of the shape? They're asking us to find the perimeter of the shaded region, so we just know it's going to be the line A to B plus the arc A to B, which is what we've done over here, line A to B plus arc A to B. We already know that arc A to B is from what? They already told us it's 9.6, so just 9.6 plus whatever this distance is. Isn't this just looking for the distance of, do you remember this from IG? Tell me if this corresponds. Does it look like a lot similar to this scenario from IG? This one? Does it remind you of the cosine rule? As in any side squared is equal to the other two sides squared added together minus 2 times the other two sides multiplied by cosine of that angle. It's perfectly set up like that, isn't it? So over here, what we've really done is we just used the cosine rule. That's all we've done over here. We just used the cosine rule for AB. Rearrange for that and then just add it on to the 9.6 they give to us in the question over there. Number 7. Range of f. Do not be disorientated by that expression. It might look a little bit strange, but the range is, remember, by definition. You're just trying to look at what 2 minus 5 over x plus 2 overall can become. If they're asking us for the range of f, they're just trying to ask us to, can you describe all the possible numbers that 2 minus 5 over x plus 2 can become? Are you following this so far? Like, you know the definition of range over here. And what are all the different numbers that 2 minus 5 over x can be? It's just going to be what? It's determined by what you can replace the x with. The 2 doesn't change, the 5 doesn't change, the minus, the plus, the 2 doesn't. Only the x over here changes. It's because the x over here changes, this overall answer changes, is what you realize. And if they're telling you x must be bigger than negative 2, all you got to know now is just plug in some examples of numbers bigger than negative 2. Try it. 2 minus 5 over, so do this. 2 minus 5 over, what's an example of a number bigger than negative 2? 0. 0 plus 2. See how that works? You get negative 0.5. What's another example of a number bigger than negative 1? 2 minus 5 over 1 plus 2. Now on your calculator, you have a third. Now you press upwards, negative a half. So the number's what? Do you see what's happening over here? Because x has to be bigger than negative 2, you then realize, because the number on the bottom over here is x plus 2, this number on the bottom is only getting bigger and bigger. If you're doing 5 divided by a number that's getting bigger and bigger, you're only going to be what? You're only going to end up with a number that's closer and closer to 0, isn't it? 5 divided by x plus 2, and x is being bigger and bigger, just means that 5 is always going to be divided by a number that's bigger and bigger than... Yeah? 5 divided by a number that's bigger and bigger is just going to be 5 overall, divided by a number bigger and bigger. It's going to create something that's closer and closer to 0. So 2 minus a number that's closer and closer to 0 just means what? It's never going to be bigger than 2 now, is it? See how that works? That's as you can tell, it's always going to be smaller than 2. Because 2 is always going to be multiplied by subtracted by a 2 minus, it's always going to get minus by a number that's positive, and it's always going to get minus by a number that's getting closer and closer to 0. Part B. This is just a rule with these types of questions. Whenever you're dealing with inverse functions and they're talking about domain and whatnot, you always draw the table, remember? It's just like a trick. The way you use the trick is, remember that rule? Domain of f of x is, you've definitely heard about this, it's a cliche by now. Domain of f of x is inverse of it. Yeah, range of inverse function, that type of thing. What it really looks like in practice, the easiest way to apply this is just, if you wanted to find out what the domain and range of the inverse function is, all you got to do is you draw a table first. So the way we did this is, the first thing you did was drew a table, f of x and inverse function x. The next step was just to write down what we have, which is the domain x bigger than negative 2 and the range less than 2. So x bigger than negative 2, domain, f of x less than 2, range of this. So these two we just copied in, didn't we? Do you follow this? We just copied those two in. Yeah? For f of x. And the way we apply the rule is we can fill out the rest of the table because we didn't need to think about these ones. We just literally copied in. If this was range less than 2, that means domain is less than 2 for the inverse. That's why we just copy down x less than 2. If this was the domain for f of x bigger than negative 2, we just write down the range of this is bigger than negative 2, which is why we wrote down inverse function bigger than negative 2. Once we have this, then we just go ahead and find the domain. Excuse me, the expression for the inverse function, which starts from doing what? Y is equal to this and rearranging for x, which is what we've done over here. There's a lot of ways to go about doing this. What I recommend first is, remember when you want to rearrange for the x, common sense tells you what? You want the x by itself. So wouldn't it help to take this minus 5 over x plus 2 and put it to the left-hand side, where it now becomes 5 over x plus 2 positive, and we can move everything else to the other side that doesn't relate to the thing containing x? Does that first step make sense? Yeah? And the next step is, well, we got to get x by itself. X is in a function fraction right now. If x is stuck inside a fraction right now, we need to get rid of that fraction. So we do 5 over, we do cross multiply, and cross multiply, we respect the math over here, which is we know that two components multiply together, you put brackets there. And then we just trust the math over here, we just expand. Once we expand, what's common sense tell us? We want the x's by themselves, don't we? Everything containing x by itself. So we move everything involving x to the other sides. We minus xy to that side becomes xy. 2x to that side becomes minus 2x, and everything else unrelated to the x fucks off to the other sides, just like that. And we know we want to get the x by itself. What technique exists such that you can get the x by itself? If you have two components of x, factorization here. And that's why we factorized over here. Right inside you can see how that simplifies out. Then we can rearrange for the x over there. Whatever's on the right divided by y minus 2. Okay? And the final part is just write down. Remember, this is from IG. How to find inverse functions. I'm sure you know how to do this. And then domain over here, we just copied in from what? Do you see why that table helped? If we just start doing the table from the get-go, we just copied in what the domain is. Instead of having to individually, oh, well, what's domain over here? Like, you don't want to have to think about it. See how this habit really helps? You draw the table by default for every type of question like this. Every single time they ask you to find an inverse function and you're fucking around with domains, you just draw that table over there and you just copy in what you got. Just reverse copy. Right? You wrote down these two, these were just copied in from information provided in the first part, and you can just directly copy in, just reverse the orders for the inverse function domain and range. F of g of x just means shoving g of x inside of the x inside f of x, which is what we sort of explained over here. You see how that works? Because g of x is x plus 3, so you substitute x plus 3 into the f of x. What is f of x? F of x is this. The x over here got replaced with what? X plus 3. That's what it means, doesn't it? See how that works? So you just do 2 minus 5 over x plus 3 plus 2, which is what we've done over here. Don't need to be told that can be simplified. And when we simplify this, why do we do 2 over this? In case you need to see the algebra for this. Everything at the end of the day is just algebra. Everything algebra. All we've done over here is, this is where you realize, if you want to write your answer in one fraction, because they're asking you to write the answer in one fraction, isn't it? Like, you've already found what, like, this already answers the scope. 2 minus 5 over x plus 5. That answers the question already for f of g of x. But they want you to write it in this form, which means what? You've got to turn this thing, which is something that doesn't involve a fraction, into both of these overall become one fraction. Only way you can do this, you got to change this into a fraction. Agreed? So how do you change 2 minus 5 over x plus 5 into a fraction? You realize, oh shit, 2 is the same thing as 2 over 1. 2 over 1 is the same thing as multiply bottom by x plus 5, because you know whenever you're adding two fractions together, you must make sure the denominator is the same. If we multiply the bottom by x plus 5, we do the same to the top. And you see where this is going now. Oh shit, x plus 5 now, which is 2x plus 10 minus 5 like that, and that's how you can tell it became 2x plus 5 over x plus 5. First term is a, second term is a squared over a plus 2, and if the triangle is geometric, come on. Basic geometric. If I told you you have a geometric of 4 and then 16 and then 64, doesn't it just mean you do the second term divided by the first term, 16 divided by 4 to get 4, 64 divided by 16 to get 4? And that relationship over here, geometric just what? They're testing you on, hey, do you know that if it's geometric, anything divided by its previous term is going to give you that multiplication factor? That's kind of where they're hitting that over here. Because you want to find the value of a over here, especially when you see the 5 marks, you know you've got some motherfuckingly long type of algebra thing about to happen, yeah? And how do you do that? You need some sort of equation involving a to work out what a is. This is where you'd realize you clearly have to use the sum to infinity using this relationship, second and first term. You immediately have the awareness. Second term, first term. I know for a fact that the geometric second divided by the first, what does that give to me? It gives me the r value, doesn't it? It gives me the multiplication number every single time. Therefore, that's how we got r is equal to this first thing divided by the first term. If you're wondering how this simplifies into this, that's quite concerning. Okay, this is very basic algebra over here. But if you are wondering, here's how it simplifies out. As you're wondering, like, how the fuck do we just get from this to this in one step? You should be able to just tell, okay? You should be able to just look at it and be able to tell that this is what happens. But if you're unsure, don't worry. You can just, while you're in the exam, right? What I'm saying is, if you really have to, if you know for a fact this has to be simplified, and you don't know how to do it off the top of your head, just in one step, write it out the long way if you have to, is my point. Over a just means divided by a, which means a squared over a plus 2. There's nothing stop. There's plenty of working space to do this, so don't worry, okay? If you have to work it out, and then this way you have to tell it's going to be the same thing as a squared, a bracket a plus 2. Ah, that's how it simplifies out. A over a plus 2. All roads lead to Rome, okay? If you don't spot it in one step, just work it out. Because you know basic algebra rules, and you can definitely work it out. Once you found what the r value is, they tell you the sum to infinity is 264, which is first term, which we know is a divided by 1 minus r, equals to 264, which we can replace the r now with something involving a, can't we? Because a over 1 minus r equals 264 is fucking useless. You've got two different letters, and you can't solve two letters in one equation. If you replace the r with, see what I mean? Like, you spot that r, if you were to replace it with a over a plus 2, that's going to create one equation involving one letter now, doesn't it? Which you know guaranteed can be solved. The way I'm explaining these questions to you is really just focusing on the logic process, like how in real time you would be thinking about this question, along those lines. Are you following what I'm saying here? That's the focus, okay? You replace the r with a over a plus 2. Are you there? You still awake? I mean, this is pure, you know? It is a mental exercise, it is. Like, it's an endurance exercise in a lot of ways. If you're not used to this, it is absolutely an endurance exercise. And so if you have a over this equals to 264, remember one of the easiest ways to go about doing this, you see the bottom fraction of it, that looks fucked, doesn't it? Could you not just turn that into one fraction? And you turn that into one fraction by doing what? Remember, 1 is the same thing as anything divided by itself is 1. Why wouldn't you just do a plus 2 divided by a plus 2 then to replace that 1? Because if you do a plus 2 divided by a plus 2 to replace the 1, that's how you can convert these two into the same fraction now, can't they? A plus 2 divided by a plus 2 minus a over a plus 2 just becomes a plus 2, copy down denominator, a plus 2 minus a like this, and you can tell that simplifies out into 2 over a plus 2. And then you can just do what? A is equal to this thing multiplied by this, can't you? Or even better, can you just do a divided by this? A divided by 2 over a plus 2 is the reciprocal. A divided by 2 over a plus 2. We'll show you the algebra over here in case you need to see it. A divided by this part, isn't that the same thing as a multiplied by a plus 2 over 2? A divided by 2 over a plus 2, isn't that the same thing as a multiplied by this thing flipped? See how that works? That's how we got a squared plus 2a over 2. And yeah, the rest is just cross multiply. You get this quadratic expression. You get negative 2 or negative 4. Why do we ignore the negative 4? Because look at the question. They tell you a is positive constant. And so we got the answer a is 22 only. The part where they say the progression is arithmetic and a is equal to 6, and you want to find the minimum number of terms for less than negative 480. Step 1, a is equal to 6, no problem. D, you got to find the d value. You're not confused why we got to find the d value if they tell you it's arithmetic. You can't do the question if you don't have the d value. You need the a and the d for arithmetic. Agreed, yes or not? And how do we find the d value? Well, we already know from the first part of the question, right? They tell you the second term is a squared over a plus 2. First term is a. If you take the first term, second minus the first, isn't that going to give you the d value, the common difference? And if you know from the question that they tell you a is 6, you see where we're going with this. 6 squared divided by 6 plus 2 minus 6. That's going to be where we got negative 1.5 from. A is 6, d is equal to negative 1.5. And then how do we get the, they say the least value of n required for the sum of the first n terms to be less than negative 480. Sum of the first n terms to be less than negative 480. Is there an expression of negative 19 that represents sum, yes or no? This is the expression then, isn't it? We copy down that expression. We know the information given to us, the way we write it is that sum has to be less than negative 480, which means this expression is less than negative 480. And you see how that just perfectly fits also, because look at it, we've got the letter n in there. We've definitely got to have some sort of relationship we can use to get n. That's what we're trying to find over here, right? Something involving n. If our equation doesn't involve n, we know we're on the wrong track. So we know we're on the right track over here because we've got something that represents the sum that involves the letter n, and we know that has to be less than negative 480, which is how we depict it over here like this, using the inequality. And this is, you just do the math over here, because you don't want a to remain a. A is 6, replace a is 6. You don't want d to remain d. D is negative 1.5. This is just doing the basic algebra over here to simplify and expand, all that stuff. When you get to this step over here, you can tell it's going to be a quadratic. A lot of ways you can go about doing this, but just understand you're trying to convert this into a quadratic like this. And this quadratic over here, you can tell is fucked, as in you can't just factorize that. You have to use the quadratic equation to work out what n is, so you go ahead and work out what n is, which is 30.195. And now, are you trying to work out n, or are you trying to describe what n has to be so that this is definitely less than 0? Make sure you focus. Did we have this equation equal to 0 or less than 0? Yes or no? Which one? If it's less than 0, we're not looking for n equals to 0. 30.195 something is the number that gives us equals to 0. By the way, when you're doing this, when you're solving this quadratic, using the quadratic equation, you actually end up with two answers. Why do we ignore the negative one? Because n can't be negative, right? N is telling you which term in the series, like how many terms to add together. So we ignore the negative number because you can't have a negative number of terms. My point is this, 30.195 recurring is the number that makes this equals to 0. We're trying to look for the smallest possible value of n so that it's definitely going to be less than 0. Yeah, 30.195 makes it exactly equal to 0. Why did we round it up to 31? You're confused, isn't it? Like, why did we not round up to 30? Like, how do we know to round up to 31 and not 30? This is where you realize, okay, they're testing you on logic over here. Do you fathom? A is 6, D is negative 1.5. If the series keeps going further and further, it keeps progressing, what's the implication? Like, what's the awareness you have over here? If the series keeps going on, are the numbers going to get bigger or smaller? More positive or more negative? The d value is negative 1.5. If you keep adding terms on, which is what the sum formula is, you're going to make the answer overall more negative, isn't it? The value is going to be more negative. Yes? So therefore, if you know 30.1 is the one that makes it exactly equals to 0 over here, don't you need like at least above 30.195 to make it less than 0? Because the more you add, the more negative it's going to be. See how that works? That's why you round it up to 31. And also you realize you can't have a point decimal number of terms to add together. Add together the first 10 terms. Okay, that makes sense. Add together the first 20. Yeah, that makes sense. Add together the first 10.1. What the fuck? What's the point? So you realize you need to round this to a whole number and you need to round up. Because 30.195 makes it exactly equal to 0. 31 perfectly makes it just less than 0. Which is what you're looking for over here. And you know to round up because based on the question over here, when d is equal to negative 1.5, you can tell the greater the number of values you add on, greater the number of terms you add on, the more negative your answer is going to be. Number 9, equation of the curve. This is just integration, okay? Very easy. And you know integration over here is just do the basic brackets rule. As you need to write this into an acceptable format, you know by now that 2 over x minus 1 to the power of 3 is the same thing as 2 times x minus 1 to the power of negative 3. As in we know they're easy to integrate formats. needs to be a number times something involving x power number. When you see the bracket over here, this is the special case. You've probably already forgotten the special case scenario. Yeah? The special case is as long as you have a bracket involving only x power 1. Is the bracket inside? Is there only one bracket over here? And is it only involving x power 1 inside the bracket? Yes or no? That's when you can apply the special rule. Special rule is just what? You pretend this is negative 2x to the power negative 3. As in, you pretend x minus 1 is just regular x. Negative 2x power negative 3 is just negative 3 plus 1 divided by negative 2, just like that. So that's what we've done over here. But we must always include one extra step, which is divide the whole thing by the derivative inside there, the differentiation inside the bracket. In this case, it's just 1, so we don't need to do anything about that, because anything divided by 1 doesn't change it. That's how we've integrated over here. You can tell this integration is not complete because you have a missing plus c value. Why do we have plus c? Because every single time you integrate, there's always a plus c, and use this relationship over here, because 0, 3 is another way of telling you when x is 0, y has to be 3. That's relationship there, isn't it? If you replace the x with 0 and y with 3, 0, you're going to rearrange for c is equal to 2, and that's how you got this full expression. Showing that the x-coordinate of p satisfies this equation, 2x plus 1 times this minus 1. This looks abstract as fuck, doesn't it? Except, remember, this is the scenario. What are you going to do when you have the scenario where you don't have the full solution off the top of your head on how you go about getting the full answer? Just start writing something that you know is going to be relevant. The more you write down, the more you depict it, the more obvious it's going to be. And you'll arrive at the full solution by default. What does this look like in practice? Have a look at this. If you want to find the... Are they fucking around with tangent? Tangent to the curve at 0, 3? Do we need anything else other than... Do we need any more of an instruction to then go find the equation of the tangent? Yes or no? Would you then need to be told to find the tangent? Would you start finding the tangent? What would you do? Like, we ain't fucking around, yeah? We're going to find the equation of the tangent here, yes or no? Is the tangent a straight line? If it's a straight line, does it apply to y minus y1, that universal formula for every straight line equation? Y minus 3 equals to x minus 0, multiplied by the gradient of the tangents. What's the gradient of the tangent? What's the gradient of the tangent? Isn't the gradient of the tangent just... Isn't the tangent on the curve? Do we not have the gradient? Do you not have the differentiation of the curve? Isn't that just the same thing as plugging x equals to 0 into that instruction to find the gradient at x equals to 0, which is the gradient of the tangent? Which is what we've done over here. Plug 0 into that, you'll get 3. So we found the equation of the tangent over here, no problem. And then all we got to do now is, they're saying, what even is the point P? The point P, how would we find the point P? They're talking about point P is when it intersects the curve again. This is the equation of the tangent. Tangent touching the curve is what they're mentioning over here. How do you mention tangent touching the curve? How do you mention tangent intersecting with the curve? Isn't that just simultaneous? 3x plus 3 is equal to the equation you found over here for the equation of the curve, which is what we've done over here now, isn't it? 3x plus 3 equals to the equation of the curve we found. Now from here, this is all you're going to realize now is, to prove it satisfies this equation is just prove, if you were to find the point of intersection, which is 3x plus 3, it starts off like this, equals to x plus, yeah? X minus 1 power negative 2 plus 2. It's to prove how this eventually can transform into this. If you can rearrange this equation to show it becomes this format, that's how you know it's the correct one. That's how you know it satisfies this equation. Because only, P would only satisfy this if it came from the intersection scenario. You just need to prove that this intersection equation format becomes this. You see what I mean? If P satisfies this, then that means this equation must have come from this. So you just have to prove how this equation becomes this. So without further ado, look at this. The final thing is there's no negatives, there's no negative powers. You've got a negative power over there. You realize the only other thing you can do to get rid of a negative power is transform it into anything to power negative 2 is the same thing as the power 2, just 1 divided by. That's what we've done for the first line of working. Very simple over here, isn't it? But that's the most crucial part over here. We realized the power negative 2 is the same thing as 1 divided by to the power of 2. And then we realize, well, that final thing doesn't have a fraction. Let's get rid of that fraction. How do we do that? We multiply both sides by x minus 1 squared. So that's what we've done over here. Multiply by x minus 1 squared. X minus 1 squared times this whole thing on the right hand side. How many components are there on the right? 1, 2, 3. Which means if you do x minus 1 squared times everything on the right hand side, it means individually they get multiplied by x minus 1 squared. X times x minus 1 squared. 1 over x minus 1 squared times x minus 1 squared just becomes plus 1. Plus 2 times x minus 1 squared just becomes plus 2 bracket x minus 1 squared. And as we further move along, we want everything to what? Take a look at this question. They told us over here the whole thing right hand side is 0. We've got something that's not right hand side 0, so wouldn't it make sense to just make the right hand side 0 now? So we see this? We want to make it look like this. We can tell the right hand side 0 over here, so let's just make the right hand side 0. So we move everything here to the left hand side. This is a product, minus x bracket x minus 1 squared, minus 2 minus 1 equals to 0. And it's already starting to look more like this, agreed? It's starting to look more like it. And this is where we realize x minus 1 squared times this, x minus 1 squared times this, x minus 1 squared times this. Oh shit, it can be factorized, can't it? Do they all three of these terms have x minus 1 squared in common? So we pull that out, x minus 1 squared, put a bracket. What multiplied by x minus 1 squared gives you 3x plus 3? 3x plus 3. What multiplied by x minus 1 squared gives you minus x times minus x. What multiplied by this gives you minus 2 times minus 2. Bracket. Equals to this, yeah? And you can tell that stuff inside the bracket over there simplifies into 2x plus 1, which if you reverse the order, it's allowed. This times this is the exact same thing as this times this. And now we have something that identically corresponds to what we wanted to prove over here. It satisfies. Verify x minus x equals to 3 over 2. Satisfies this equation. What's the equation? This is the equation. How do we verify it satisfies it? Doesn't satisfies mean if we substituted x equals to 3 over 2 into here, it better equal to 0? That's what satisfies mean, right? So we substitute that in, and we prove that doesn't equal 0. So we prove that. They see the calculation, they know that we proved it. They know we understand it. And then just find the y-coordinate p. Well, what the fuck even is p? P is what? P is a point on the curve. Do we have the equation of the curve? Of course we do. We found the equation of the curve in the first part. So we just substitute what? X equals to 3 over 2 into the equation of the curve, which is where we get 7.5. Number 10, maximum point on the curve. Maximum point, every single maximum point. I mean, you can tell. Come on, look at this titty shape over here. You can tell the middle over there. Bam, right there. That is obviously going to be the maximum points. That maximum point over there, how do we find it? This is testing you on, hey, do you remember differentiation gives you the gradient at every single one of these points? What's unique about the gradient at the maximum is just what? The gradient is going to be 0. So we just make the differentiation equals to 0. Without further ado, we differentiate. And when we differentiate equals to 0, we rearrange to solve it and we get x equals to 4. We only found 1 point for the stationary point here, didn't we? Anyways, you see, you get the point. X equals 4, substitute that into the y equation to get the full coordinate, 4, 9. And obviously make sure when you're differentiating over here, you're not confused about how. Remember, there's a special rule. If we have anything bracket involving just an x, we can just pretend the bracket is regular x. Minus x to the power 3 over 2 just becomes 3 over 2 in front. 3 over 2 minus 1. But we've got to include one extra step, which is times the whole thing by the differentiation inside the bracket. This is included in the Google Docs over there. If you go to the Google Docs for the exam guide, over there, in case you forgot, right? How to differentiate for every main scenario you come across. It's included in there, that exercise. Now, part B. Verify that the line AB is a normal to the curve. The only way you can verify, first off, do you know the normal is just a straight line? Yeah? It's a line that's perpendicular at A. That's what the definition of the normal at A is. That's what you've got to be aware of. So it's just what? A has a tangent. The line that's perpendicular tangent at A is the normal. You just got to prove that normal is actually the same thing as line AB. What's special about the normal? The normal is just going to have the same gradient, isn't it? Like the line AB, if you were to prove as the normal AB, that means the gradient of AB better be the same as the gradient of the normal at A. So let's find the gradient of the normal at A first. At A, the gradient is just going to be 1.5 substituted into the differentiation equation over here, yes or no? Which is 3. So therefore, the perpendicular gradient is just negative 1 divided by that. So we've proven over here that negative 1 over 3 is the gradient of the normal at A. We just need to prove what? The gradient of line AB is the same as negative 1 over 3. Gradient AB is also negative 1 over 3. Proven. Done. Equation of the shaded region. Area of the shaded region was what? Before you do this question, this is where you need to realize. The area over here, integration, when you put exact limits in, is how you find the areas on any curve. This is basic integration over here. Like, you should not be attempting this unless you actually know just the basic formulas of integration over there, like what the premise is. The premise is, if you ask to find the area of the shaded region, is really just what? Finding this area first, minus this area. Okay? Which comes from what? So the area is actually from two different areas over here. It's the difference between the two areas. Area 1, which is this curve area, minus the trapezium area for the line. How do you find the area for the curve? It's just going to be integral of 1.5, 7.5. As in the numbers we put over here, remember, for integration, give us the instructions on which part of the curve we want to see the area with the x-axis on. Remember this technique? And we just put over here 9x minus bracket 2x plus 1 to the power of 3 over 2 dx, just like that. Okay? And that's just going to be, integrate that, 7.5, 1.5. 9x, right? The same thing as there's 1 over there, so it's just 2 over 2, yes. Remember the special rule? If we see a single bracket involving x and the bracket inside only has x power 1, that's a special case. What do we do in the special case? We pretend that bracket is a regular ass x. Minus x power 3 over 2. Say, for example, if you were to integrate that, wouldn't that just be negative x? That's 1.5 plus 1, so 2.5 divided by 2.5. Yes or no? Just focus on right now. Do you understand how this integrates into this? Basic scenario would work like that, isn't it? So what I'm saying is, if you identified special case over here, which it is, as in if it's just a single bracket involving x to the power of 1, then you can pretend that bracket is a regular x, which is the same way minus x becomes this. It's going to be minus the bracket to the power of 5 over 2.5. But you just got to only have to do one extra step, which is divide the whole thing by the differentiation inside that bracket, which is 2. And if you divide by 2, you'll see it's the same thing as putting a 2 on the fraction over there on the bottom. Message me if you don't know this, but this is very important algebra basics over here. As in, you're not confused about why divided by 2 just means put a 2 on there, okay? Yeah? Surely? Yeah? And yes, if you substitute 7.5 into there, minus substitute whatever 1.5 into there is, you're definitely bound to get the right answer. Which is what we've done over here. Okay, you should definitely get 44.6. And for this other area over here, how do we find this other area, the second area? You need the equation of this line first then, don't you? Isn't the equation of the line just the AB equation? We already know the gradient of AB is from the first part of the question. Like part B over here is negative a third. So just what? Y minus y1 equals to m bracket x minus x1. Yeah? That's what we've done over here. We found the equation of the AB line, and we just do basic integration over there like that to get 27. Curve area minus the other area for the line AB, the trapezium area, 44.6 minus 27. Of course, it's going to give us the area of the shaded region. Of course, it's going to give us the area of the shaded region over here like this.